Hello everyone, this is the TM105 meeting 5. Now this will be one recording for all of meeting 5, so let me go to the objectives. Objectives of today's meeting is to basically describe what arrays are and why they are necessary in programming. Now, one other objectives is to tell the difference between primitive and reference types. Now, we already saw this objectives previously. You see, when we created the strings and compared strings, we discussed the difference between the int, the double, which are examples of primitive type, and the string, which is a reference type. So this objective is basically covered, but it is listed over here because arrays, they use reference types as well. Now, to declare array reference variables and create arrays, so this is basically what arrays are. How do we create them? Accessing the array elements, so we will see this, so still in array. Now declare, create, and initialize using an array initializer, so still other way of creating array. Program common array operations, still dealing with arrays. And then over here the last two are for something called a two-dimensional array. You see, all the few objectives at the top are for 1D array. Now later we will take the two-dimensional array. Okay, before I go to NetBeans, let me open over here. This is my whiteboard. I will be using this board to explain a little bit what arrays are. You see, in our programming, we usually have something like this: int number, and then I would say number is equal to 5, for example. Alright, this is my first piece of code. Now let me show you what really goes on in memory over here. Let me put a box. Alright, this is a box, and when I say int number, I will be creating a variable location. You see, an int is going to take only 32 bits, so this will be referenced in my program as number. So the first line, int number, created this memory location. So let me put over here that this is my memory. I can modify the color. Alright, now when I say number equal 5, you see 5 is an integer, and the binary representation of 5 is going to take less than 32 bits, so it fits in my integer location. You see, this is a primitive data type, very simple, very basic. Now let me go to the array declaration. The same way that I declared a variable, I need to declare an array. Now the only difference is that after the int, you put these square brackets, and now it is more reasonable to use a name like numbers. Alright, a name like numbers. Now when I wrote this over here, let me put it in a different color. You see, int array numbers. You need to think right now that what you are doing is, what you are doing here, let me try to copy this again. I don't know why copying on this board has become very difficult. Alright, so here it is, another memory location. Let me put it over here, and this is the memory location for numbers. But now I did not give it a value. Arrays you cannot directly, well, you can, but not using this the way I am writing it. There is a short way of creating arrays. I will explain it in just a second. Now the next line, you need to create these memory locations. So you write numbers is equal. You see, I am creating, I am assigning something. Now this assignment, I need to create new. Just remember the scanner. The scanner is a reference. We use this new keyword. Numbers is equal to new int of, let's say, 5. You see, what I am telling Java over here is that I need to create somewhere in memory 5 new integer locations. So Java is going to, let me put them next to each other for simplicity. Java is going to create 5 boxes for me. Okay, hopefully the box was copied properly. No. Again, the same copying problem. Alright, here it is. So this is my second box. Here's my third box. Here's my fourth box. And here's my fifth box. Alright, these would be created somewhere. Let me put over here the way we took referencing before. Assume these were created at 18034 at some location in memory. Now this is not the actual value of numbers. This is the location in memory where this array could be found. So what you are actually doing is creating a reference to these locations. You see, I'm creating a reference to 5 new integers. Now these integers, they have indices. I will write the indices using a different color, starting with 0, 1, 2, 3, and 4. We have seen these indices with the strings before. We have seen these indices with the strings before. Now let me continue my code. How do I store values? Numbers, and you see, you are accessing, you use these brackets. You need to access a single location. Numbers of 2 is equal to 6, for example. So you go to numbers of 2. You see, this is numbers of 2. And you put the 6 in place of it. Now, there is no need to put them in order. So there's numbers of 0 is equal to 4, for example. So now I go to numbers, I follow the reference, I reach number of 0, and I can put the 4. Now just like with arrays, with the string, sorry, numbers of 5 is equal to 7. This will not give you a syntax error. However, this will give you a runtime error. You see the problem? You do not have index 5, so be very careful. This will give you a fatal error at runtime. So this is fatal error at runtime while the program is running. Fatal error at runtime. So while the program is running, it will crash. It will not be able to continue. Alright, so now you get the basic idea of the difference between a primitive data type and the array, where the array is a reference variable similar to strings. So reference data types, you just store the value right away, int number equal 5. With arrays, you have an additional step where you need to create the array in memory, store the reference, and then give it the values. Alright, now another way to do this. You see, creating the arrays could be done in a different way. So let me go directly to the other way. Instead of writing it this way and filling it up, you could write the following code. Int, and this is an array. I will call it numbers, and I will directly put the equal, and I will give it values using the curly brace. So this is 7, 2, 6, and 8. I will close the curly brace, use a semicolon. You see, this is a short way of creating the array and directly giving the array values to be used automatically. This is a statement. What happens in memory? Here, let me add my memory back. Alright, this is my memory. First, I have a variable. The variable is called numbers. So I will be creating, Java will be creating this memory location, which will be called numbers. Now, I am telling Java that numbers is an array, and I am directly telling Java that this array contains 4 elements. The value of the elements are what is given. So Java is going to automatically create. See, this is the first one, and it will give it the value 7. Then it will automatically create the second one. It will give it the value 2. Then it will create a third one over here, giving the value 6, and the fourth one, the last value, and I gave this the value 8. Now these will be created at some location, let's say 10612. This is the location in memory, so here it is. This will be a reference. This is where the array will be created. So this is a short way of directly creating the array and filling it with value. Well, this is not always the case. When you need to fill the array with values, it means that you already knew the values of the array. But most of the time, you do not know the values of the array. These values should be taken as input, and then they should be processed. You should go ahead and try to process them. Now, in this specific example, you might be wondering, what are the indices? You always start with index 0, and then you increase 1, 2, and 3. You see, 0 to 3, these are 4 values. So I can access my values by simply using this location. So I can, for example, system.out.println, and I can say numbers of 3. You see this line that I added over here. In case I have an output, let me put an output box. Let's assume this is my output. Alright, here let me write this is my output. So when I run this program, this is what I see. Now on the output, I am printing and going to a new line the value that is found in numbers at index 3. You see, this is the index 3. The value is 8. So at the output, you will see 8, and you go to a new line. Alright? So let me put over here an arrow. This will give you the following value. Why did it give the following value? Because I am accessing index 3. Index 3, I have the following value, which is 8. So this is the value that will be printed. So numbers of 3 means print the value that is found at index 3. Alright, now let me briefly go to the slides. Okay, here are the slides. So problem, you can read it. Differences between types, you know them, you can read them. Arrays, you have a specific collection of data, you can read these. Introducing arrays, the difference between primitive and reference, everything is discussed over here. How to create an array, you can read this. I created something like this. Now they are creating something over here called a list. Alright, and this a list has 10 new integers. I will be doing a combined for these two together or these three together, so we can combine everything in one step. We'll be doing this in our programming in just a few seconds. Now, one dimensional array, another way to create it, now they are using the type double over here, so these two are the same. You can read this slide and be careful not to mix together. You either create the array and give it all the values in one statement, or you have to do it in more than one statement. Alright, read all the examples. I will go directly to this example. I will be doing this example with explanation. Why should we use an array? So I'll be doing this example at slide 15. So let me go directly to my NetBeans. I will start a new project, Java application. I will not be modifying the name. This is the analyzed numbers. You can modify the name if you like. I'm just using it over here for the purpose of explanation. So let me zoom in a little bit. Okay, and let me remove all of these comments. They are not giving me anything beneficial. I will zoom in a little bit more. Alright, I will prepare my program to take user input. So this is import java.util.scanner. Scanner input is equal to new scanner of system.in. Now I need to take from the user. I will not be using a lot of values. The example in the slides, it simply uses just 100 values. I will be using 10 for simplicity. So I need to take from the user 10 values. Now I will also be taking them as integers. This is the easiest type to work with, but of course you can, instead of integer, you can create a double, you can create a string. It could be an array of anything. So it could be an array of strings, arrays of doubles, array of integers, array of your own created classes, and you will see this in another course. Alright, so I need an array. You see, array of integers. You put this. Now I need an array of integers. You need to give the array some sort of name. The main name should be meaningful, and it is better to use a plural name because you have a lot of values. So I will be reading from the user several numbers. So here it is, int array numbers. Now you can write it as two lines. The first line, int array numbers. The second line, numbers is equal to new int of 5. So create 5 locations. But these two lines in programming, you know, there are several ways to write the things. These two lines could be combined together. Instead of writing it as two separate lines, you can write, I need an int array called numbers, and directly in Form Java create the array with 5 to hold 5 integers. So let me remove these two lines. You see, they are the same. I will get rid of this error, but this error is because I am redeclaring my array. So I can remove these two lines, and this is an easier way to create my array. So int numbers, and it is a new int of 5. Now I need the program to do two things. First, I need this program to calculate the average. So I need to take okay, I used 5, let me use it 10. 10 is better. I need to take 10 values from the user, and then I need from these 10 values to calculate their average. And then after calculating the average, I need to check how many numbers are above average. So I need a set of variables. You see, my numbers are all integers. So I will have an integer called sum, and I will initialize it to 0. Now, concerning the number of values, you see the array has 10 values. I will do slight modification at a later time because all my code will be based on this number. What if I need to do testing? Usually, when you write a program, you do testing with a small subset. Like you can start your testing with only 5 values and then take the 10 values and do the testing because it's easier for you to be able to process them. So this number 10, I will be modifying it. Anyway, now I know that the size of the array is basically 10. Now this is not really relevant because instead of using values, I can give you several ways to do it. Now what I need to do later on as an integer is the number of grades or numbers that are above the average. So I need a variable count to be 0 as well. Now I know I need to calculate the average, so this is double average. And you can initialize it to 0.0 or you can keep it without initialization because this average will be modified before being used. You will give it a new value based on an expression before using it. Alright, now let's start our program. The first step is taking input. Provide a prompt system.out.print, enter, and I will put over here 10 numbers. When you have an array, you need to take each number separately. Let me show you how I will do it and then how I will make use of loops. Numbers of 0 is going to be equal to input.nextInt. Okay, I added 6 by mistake. Then I need numbers of 1 to be input.nextInt. Then numbers of 2. Well, what if I do not have 10 and I have like 1,000? So should I keep on writing 1,000 lines of code? Can't you see that I am repeating some action? You see, I am repeating the input, repeating the assignment, but I am storing them at a different index. Alright, now this should be very obvious that because the index started with 0 and is going to increase, we already know that we can write this using a for loop. You see, these 3 lines, the ones that I have, I write a for int I equals 0, so this is the index, starts at 0. I put a condition over here, I will add it later, and then I have the I++. You see, I will be adding my values. Now instead of writing several lines, this line is going to be simply be numbers of I. The only thing I need to make sure of is where to stop. You see, it's a very common mistake to write I less or equal to 10. Be very careful. We have 10 values in the array. Means the values are from 0 to 9. So I should remain strictly less than 10. Do not put less or equal. I should remain strictly less than 10. Alright, now let me do some modification. You see, I am taking 10 values. I am using 10 over here, 10 over here, 10 over here. I will use the 10 later on. Now this is not right. This is not correct. One way of doing it is to have such sort of variable. Let's say variable size is equal to 10 and use it over here. This is size. This is size. And instead of writing 10, you could concatenate the value of size altogether. Well, this is acceptable. However, this is not the professional way of doing it. The professional way of doing it, you keep it 10 Once the array is created, you see this size that you need, Java can automatically find the size for you by simply using the name of the array, numbers, dot, and use length. You see, numbers dot length, numbers dot length. So now, if you modify, let's say I need 15, the program will say enter 15 numbers, and the loop will work for 15 numbers from 0 to strictly less than 15. I need 100. Numbers.length is now 100, so everything is modified. I will return it to 10. You see, this is the way. When you have an array, you can put the size of the array over here or declare it as a variable, doesn't matter. You are using it only once. And then you are programmatically asking Java to give you this number, the one you are used. How many values are available in the memory location referenced by numbers? So this is a way of asking yourself this question, even though you know it is 10. But this way you will not do mistakes. Take a look at the mistakes I am mentioning. Like, what if I forgot to modify the following? You see, if I was using 10 and I modified it to 100, I forgot to modify it at the prompt. Well, what if I returned it back to 10 and the loop went after the 10? You see, I do not have 100 values in my array. So never use constants. Use the value 10 only once. And anywhere you want this value, let the Java get it for you. Numbers.length. Alright? This way you will not have any errors. Your whole program will follow you. So this is the step for taking input. Now I was able to ask the user to enter values, and I stored these values at their respective locations in the array. Now let me calculate the average. To calculate the average, I need to find the sum. I need to add all the numbers in my array together. So since I have an array, I have different locations. Use a for loop for int I equals 0, I less than, numbers.length, I plus plus. Add the value to the variable sum plus equal numbers of I. You see, I added all the values. Now I have the variable sum that includes the total of adding up all the numbers. Calculate the average. Average is equal. I need to divide sum by the numbers.length, but I did a logical mistake. Now you should always be careful about these logical mistakes. Whenever you need a double value, do not perform the integer division. You see, sum is an integer and length will always return an integer. So I am dividing an integer by integer. I need to make sure that this is a double. Now, even though this is division, there is no need to check the size of the array because you are creating it with a size greater than 0. So you are not dividing by 0. So now I calculated the average properly. Now usually when you have an array and you need to figure out the max, the min, or the sum, you can do all of these using one single loop. Because searching for a maximum or searching for a minimum means I need to go over all the values. But why did I use an array? You see, I need the numbers, the number, only the count of those values that are bigger than the average. So this means that I need to calculate the average first, process the whole array, get everything summed up together, then calculate the average. And after calculating the average, now I need find the number of elements greater than the average. So I need to reprocess the whole array all over again. Well, very simple. I have an array, for loop, int I equals 0, I less than, numbers dot length, I plus plus. You see, no need to write the size of the array. If numbers of I, this is one element from the array, is greater than the average, count plus plus, add it to the variable count, increment the variable count. Every time you find a value in the array, you see numbers of 0 if the first value is greater than I plus plus, numbers of 1 if the second value is greater than I plus plus, numbers of 2. For each value, if it is greater than the average, add it to the count. Add each value to the count. Now let me provide output. I already did everything. Here's my code so far. Declaring the array, initializing my variables that I will use, taking input, prompt and the loop, calculating loop, do some additional calculation, finding loop with a condition. So this example covers everything. A for loop for input, for loop without a condition, and for loop to process the array with a condition on each element. Now I need to provide output. So this is providing output. System.out.printf average is equal to %.2f backslash n, and let me give it the variable average, and system dot out dot print, let's use printf again, number of values above average. This should be an integer, so I will use the %d, and I will put over here, this is the variable count, and let me put a backslash n and end it with a semicolon. Alright, I will save. This is my program here. Let me reduce the font. This is the whole program. This is the main. This is what's important. Now you can see it all showing all together. I still need to do the testing to make sure that I did not write anything wrong. So let me run it. And let's check each part by itself. You see, if now I am this is what I am saying in line number 12. You see, take a look at line number 12. Enter, and now I have numbers dot length. You see, it gave me 10. So Java can easily detect the size of the array, So enter, and this is numbers dot length numbers. Now it is waiting at line number 14, because line number 14 is waiting for input.next int. So now the program is waiting for at least the first integer. So let me say I have the 58. Now of course, you know, you can put enter, or you can put spaces between them and just give all the values all together. So let me have random values over here. 79, 81, 67, I already have 8 of them. I need 2 more. So this is my 74 and 76. These are 10 values. Now when I press enter, you see, even though it's waiting at 14, 14 is going to take the 58. Then it will go back to 13, the condition. Then go back to 14, take the 98. So this loop is going to record the 58 at index 0, the 98 at index 1, the 78 at index 2, and the last element at index 9, because you only have 10 values. When I press enter, these will be recorded in numbers. Then it will go over here to calculating the average. You will not see anything because the program is not going to wait for input. So the program is going to add all of these into the variable sum and then calculate the average by dividing sum over the length of the array. I have 10 values, it will divide the sum over 10. Then it will go directly to this loop at line 22. It will reprocess the array, take each element, check if it is bigger than the average or not, and increment the variable count accordingly. And finally what you will see is the last 2 lines. Oh, I should have placed an equal over here. It's fine, no problem. It will be clear. So 27, 28, and the program will terminate. So now let me press enter and see the result. You see the average is 73.90. Now this first one is less than the average. 98 is bigger, 1. 78 is bigger, 2. This one is less. 82 is bigger, 3. 79 is bigger, 4. 81 is bigger, 5. This one is less. 74 is greater, 6. And 76 is greater than the average, 7. So I have 7 values greater than the average. Alright, let me go back to the slides. Alright, here's the program that I wrote. Now, of course, I used printf. You can use the println as the last statement, but this is very similar to everything that we have. Count was declared at a later time, average was declared at a later time, but still, it is the same logic. It is the same logic. So I basically did this exercise. Alright, now the last 2 objectives, but before I go to the last 2 objectives, maybe it's better to go to the list of objectives. You see what we have covered so far. Describe why arrays are necessary, because I need to store them and process them so many times, just like calculating the average and then figure out how many are above the average. So I need to be able to store them more than one time. And if I have a lot of values, I will not be creating a lot of variables. I will be creating a lot of memory locations, but only one reference variable. So this is why we need a reference type. So array is a reference type. Declare, create using indices, done. And declare using array initializer, the one step, done. Program common array operations. Now you can cover the exercises for finding the max, the min, and so on. There are few simple exercises in the external exercises document related to meeting 5. Now I will go to the last 2. Declare variables for 2-dimensional arrays, and let me go to the slide where they introduce the 2-dimensional arrays. Well, similar to first dimensional array, 2-dimension means you have rows and columns. Now these can be used to represent a table, of course without the header. You see, the actual values you will be storing is not the header, not the first row, and not the column. What you will be storing are just the values that you have. So you can think of a 2-dimensional array as a table of values, and you will be giving meaning to these values at a later time. So what we need is how to create a table of values. Now why do we create them as a table of values and not a single dimensional array? You see, it is the same basically. Like over here I have 3 columns and 4 rows of actual quiz grades. Alright? So 3 columns and 4 rows of actual quiz grades. This means this is my data. This means that what I have is basically 12 values. So why not create a single array with 12? Well, notice the theoretical meaning that we provided. The first column represents grades of quiz 1. The second column represents grades of quiz 2. The third column represents grades of quiz 3. What if you wanted to compare grades of different quizzes? The average, for example, take the average of quiz 1, take the average of quiz 2, take the average of quiz 3, and do the comparison. You see, it's not that I have 12 values. I need the data to be structured in a way where I can check different columns and different rows. So I need this structure. 2D arrays are very useful when you need to structure your data, give your data a meaning. Alright, how do we declare them? We use the double square brackets. So not necessary, I used the keyword double. We use 2 square brackets. Okay, not necessarily the type. The type could be an integer, could be a string, could be any other type, any reference or any primitive data type. Alright, so you use the type, the data type, followed by 2 of these. Now usually the first one is for the rows, the second one is for the column. Here's an example. You see, my list is equal to new double. I need the new double locations. I need 5 rows and 2 columns. So this means that I have 10 locations in total, but divided as 5 row, and each row is basically 2 columns. And of course you can do it as one statement. We will be doing this together. Now you can read the rest of the slides. They are quite obvious. Make sure to understand everything in these slides. There is a way to create directly the 2D array. So you use the curly braces. You can try this out. And how to process the arrays, I will be doing these few slides as exercises using NetBeans, and this is it for the end of this meeting. So let me go to the exercises. Now since we know what 1D array is, I can directly go and do the 2D array exercises. These are exercises 5, 6, and 7. I will be doing exercises 5, 5, and 6 together, but I will be merging them into one main program. You see, it says create and initialize a 2D array of 3 rows and 4 columns of integers. Then take the values from the user. Then find the sum of the elements in the first row. Find the sum of the elements in the first column. And you can find the elements in everything together. Find the sum of all the elements. Or simply find the average of each column separately. Now let me write a few codes. So I will continue my program, my session, this video, using NetBeans. Let me go to NetBeans. Alright, let me close this application. So this is close all projects, and let me start a new project. Next, finish. I will zoom in. And I will prepare the program to take values from the user. So this is import java.util.scanner. I will declare the scanner. So this is scanner input is equal to new scanner of system.in. Now I need to declare a 2D array. Int. This is the first dimension, this is the second. You see I have two dimensions. I will call this array values or numbers, it doesn't matter. This is equal to new int, and let me go briefly over here. 3 rows and 4 columns. Alright, 3 rows and 4 columns. Remember that we always use the first index for the rows, the second index for the columns. Now in memory, this does not have to be like this. You can switch them, it doesn't matter. You can think of it as 3 by 4. The first one is the column, the other is the rows. But usually there is a standard to be followed. You see, in mathematics, when you need to provide the coordinates of a point in a coordinate plane, you always provide the x coordinate first, followed by the y coordinate. So always provide the rows first, then followed by the column. So this is my declaration. Now I need to take input. I will do the input slightly differently. You see, I will inform the user how I need the input to be taken. There are more than one way of doing it. You can take each row by itself, or you can tell the user to give you the data in the form of a table and read it as a table. Well, this is slightly better. It reduces the complexity. So just provide one prompt, system.out.print, enter the values as, and let me alright, it's okay, I will replace this later, as 3 rows and 4 columns. Now this time I will use the println. We will see why. Now let me write the for loop. You see, just like we did with single dimensional arrays. For int. Now I will not use I and the j. I will use row equals 0 and row is less than 3. I will modify this later. Row plus plus. Now I need another loop. For int. Now this nested loop, this is for each row. For int column, let me put just col. Alright, for simplicity. For int col is equal to 0, means a column. Col, col less than, I have 4 columns. Col plus plus. Now I need to take input. Values of a row and a column is equal to my scanner input dot next int. Alright. Now this is valid, this is correct, but again the same problems. What if you modified, let's say 6? You see, I have so many places to modify. So there should be a way to read these values, the 3 and the 4, programmatically. I will do the first modification. You see, the loop is very similar to a loop for a 1D array. The array is called values, and you use values.length. Values.length, this is the number of rows. So I will put it over here, concatenation, values.length, concatenation, here it is. Alright, let me put this on a line by itself, because this is a longer, I will reduce the font a little bit. Okay, so this is system.out.println. I placed it on a line by itself just to be able to read it. Just to be able to read it because it will be a long statement. But you see, enter the values as, let me run it now. Okay, you see this is values.length. It tells you 3 rows. So I was able to get the first value. The problem is I already used length. How can I tell what is the second one? Well, the problem with Java is that each row could have a different number of columns, but this is not what we declared. We declared an array with 3 rows, each having 4 columns. So you are safe to assume that the length of the first row, or the values of all the row, will give you the size in columns. Let me write it, you will understand it better. You see, values of I dot length, it's not I, values of row. You see this variable row, values of row dot length. Let me copy it. Let me remove this 4. I'll put it over here. Alright. Now I do not have a row. Instead of row I will use 0. Okay, so values.length, this gives you the 3. Now for the row, for the first row, when you say values of 0, this is the first row. When you use dot length, how many columns do you have? You see, in a row you have several columns. Let me show you this on my whiteboard. Here's my board. Let me create a table. Alright, now I have 4 rows. And let me have, for example, over here more columns. Doesn't matter, doesn't have to be exactly the same as the exercise, but just to explain the concept, what I got over here. Alright, let me put the indices 0, 1, 2, 3, 4, 5, 6, 7. I have 8 columns. 0, 1, 2, 3. I have 4 rows. Assume this is values. When I wrote in my code values of 0, you see, values of 0 means go to this 2-dimensional array. This is values of 0. You see how it looks like? It looks like a single dimensional array. So when you tell the Java values of 0 dot length, Java is going to count them 1, 2, 3, 4, 5, 6, 7, 8. So this value will be equivalent to 8. When you say values dot length, because it is a 2D array, values dot length is the following. I will use the green color. Alright, this is values dot length. Values dot length is how many rows. So this will give you in this example 4. This will give you in this example 8. So you are able to detect the number of rows and the number of columns programmatically. Now let me go back to my NetBeans. Let me examine this. Let's say I have 5, I have 2. Enter the values as 2 rows and 5 columns. Alright, I will stop it. I will go back to 3 and 4. Let me try it. Enter the values as 3 rows and 4 columns. I will stop it. Alright, now I will put this print statement over here. It's not nice to be lower, but anyway, it doesn't appear because of the zooming, but you know that we are providing a good prompt for the user. Alright, now I can do my processing. Let me start by calculating. This is sum in first row. How to calculate the sum of the first row. Okay, just the first row. Int, I will call this sum row, is equal to 0. Now I need a loop for all the elements of the first row. We know that the first row is at index 0. Let me go to my board. You see, the first row is values of 0. So I need a loop for values of 0. This will give me the sum of the elements of the first row. So let me write a single loop for int I equals 0 semicolon. I is less than values of 0. This is the row dot length. I plus plus. Let me add it to the sum. Sum row is equal or plus equal values of 0, and the second index is your I. Alright, let me go to my board briefly. The index over here is at 0, 0. The index over here is at 0, 1. The index over here is at 0, 2. The index over here is at 1, 0. You always read the row first, then the column. The index is at 1, 1. The index is at 1, 2. And you can continue the others. So all the indices are 0, and only the second value is changing for the first row. So here in my code, you see 0, and the second value is changing. We will try this out. This is the sum of the first row. Sum in first column. Int sum col is equal to 0. For int I equals 0. You can use I, you can use j, it doesn't matter. I is less than values dot length I plus plus. Sum colon plus equal. Let me go to my board. Let me continue. This is index 2, 0. This is index 3, 0. You see, the second value is always 0, and the first value is your index. So now you write it over here. Values. The first one is my index I. The second one is my 0. So this is the sum in the first column. Okay, before I continue, let me test these. Save. Okay, I need to provide output. System.out.println sum of first row is equal, and I will concatenate it to sum row. System.out.println sum of first column is equal, and I will concatenate it to sum col. Let me run it. Alright, so enter the values 3 by 4. Now the two for loops, I will enter the values as 4, 5, 6, 8. This is 4 columns, the first row. 1, 4, 7, 2. This is the second row, and the third row 6, 7, 1, and 3. So this is a 3 by 4. Now the program should calculate the sum of the first row, the sum of the first column, and give me the output. Let me do this over here. Let me calculate the sum of the first row. You see, 4 and 5, 9, 9 and 6, 15, 15 and 8, 23. So the sum of the first row should be 23. And over here 4, 1 and 6 is 11. So I need to get the 23 and 11. So when I put enter, you see these are the values. 23, 4, 5, 6, 8 will give you 23, and 4, 1 and 6 altogether, these will give you the 11. So this part is basically done. Now let me calculate the sum of all the values. I need to process the whole array. Sum of all the array. Int sum equal to 0. And now I need to use my two loops. For int, you can use ij or row column, it doesn't matter. I will use the row column. For int row equal to 0, row less than values dot length. This will give me the number of rows. Row plus plus. Another for loop. For int col equal to 0, col less than you can use values of 0 dot length, doesn't matter, and col plus plus. However, it is better to use values of row. Now if you are using I and j, this would be values of I dot length, and then sum plus equal to values of row and column. And let me print it. So system dot out dot println the sum of all the elements is equal, and add the sum. Alright, I will not make it more complex. This is enough. We could create like calculate the sum of each and every row, or maybe we will do this. I will do the complexity, but this would be like an optional part if you'd like to follow it at a later time. So let me run this program, and then I will do the optional remaining part. Alright, here's a run. I will be using different values, not necessarily the same. I did not memorize them. So this is 2, 3, 1, 6, and this is 3, 1, 7, 2, and this is 5, 1, 2, 4. So let's check the values. Sum of the first row, 2 and 3, 5, 5 plus 1, 6, 6 plus 6, 12. Sum of the first column, 2 and 3, 5, 5 plus 5 is 5. Here, let me take these for later. I will copy them. I will keep them for later. I will use the same values. Now, I will have over here the sum of all the elements. You see, 2 and 3 and 1 and 6, we know it's a 12. Let's add to 12. 3, it's 15. Add 1, 16. Add 7, 23. Add 2, 25. Add 5, this is 30. Add 1, 31. Add 2, 33, and add 4, 37. So this is the sum of all elements. Alright. Concerning this exercise, this is more than enough. Like you have, this is a large program. Here it is. You can see it all on my screen. So this is a good enough example, and based on the exercises, if I go to the exercises, you can see that I covered the 5 and 6. Alright, now you can do exercise 7 yourself. Alright, you can stop the video over here, or if you are interested you can continue with the exercise I am doing. I will be doing additional exercise based on everything that I already have. It will only take like 5 minutes from me. I will do it quickly. I will not explain a lot. I will try to calculate the sum of each row, not only the first, the sum of each row. So I will be modifying this program for simplicity. So I will be removing all of these, all the processing, and I will be finding the sum of each row. Alright, now let me start my first loop. For int row equal to 0, semicolon, row less than values dot length, row plus plus. Now I will use the curly brace. System. Actually, before using the curly brace, let me declare integer sum, or let me do this declaration before this loop. Even though you can do it inside the loop, declare it above. Sum is equal to 0. You see, I will reset the value of sum. Now I need to calculate the sum of the row that I have. So for int col is equal, here let me increase the font a little bit. Int col is equal to 0. Col less than values of, I use this variable row, values of row dot length, col plus plus, sum plus equal. Now notice that I am calculating the sum for a specific row, so it will be values of row colon, because this will be repeated for each and every row. Now provide an output, system.out.println the sum of values in row, and give it the row name, row, or the row value, is equal, and concatenate it with sum. Alright, so this loop, I have included a reset for the variable sum. I calculated the sum of a single row. I present the output of this row, and then I repeat for another row, resetting sum, calculating the values of the whole column, and providing the values of each row. Let me run it, and I will use the same values as before. Let me just put enter over here, and now you see the output. So you have the values, the sum of the values in row 0 is 12. We know this, 2, 3, 1, 6 is 12. In row 1, 3 plus 1, 4, 4 plus 7, 11, 11 plus 2, 13. And in row 3, 5 plus 1, 6, 6 plus 2, 8, 8 plus 4 is 12. So let me put this code over here, and I can reduce to see the whole system.out statement. Alright, this is it. I added a little bit of complexity of how we can calculate the sum of each row separately. Alright, so this is it for this video. Thank you for watching this video. Make sure to cover all the exercises of meeting 5 solutions are available on the LMS.